Hi guys, sorry I'm not there today. So today you're going to be working on prisms, and this is anywhere from 12.5 through to 12.7. I know a lot of you have already started, or some of you have already started 12.5, and that's fine, but I still want you to have a look at the start of this video just to see how I want everything set out. Okay, so if we look at these three shapes, how do we know that they're actually prisms? So the book gives you one definition, and please do read the book's definition as well because it's useful. But the way I remember it is in each of these 3D shapes, are there any pair of faces that are the same and parallel to each other? So, for example, in the first one, if I color in the base, so this bottom bit here, and this top face, I have a pair that are parallel to each other and they're the exact same size. So therefore that's a prism. With the second shape, I could actually pick any pair. So for instance, I could pick the left face and the right face, and those two are parallel to each other and they're the exact same size, so I have a prism. And finally, for this last one, I could pick the bottom and the top, and so that's a prism. That's really the only requirement for a prism. So we need a pair of faces that are the same size and are parallel to each other. If you think about it, we can add one more to this, and you'll have to excuse my sort of really bad drawing, but if you think about a cylinder, actually I should have that one line dotted, shouldn't I? If you think about a cylinder, you've actually got a prism as well, because the top and the bottom of a cylinder are a pair of faces that are the same size and they're parallel. Now, in terms of calculating volume, for starters, volume is actually really easy for prisms, and there is one rule that applies to every single prism, so please don't go and memorize a new rule for each one. The rule for the volume of a prism, so volume of a prism, is the area of the base times the height. Now, when we say base, what we mean is any of these pairs of sides that are equal and parallel. So in our four diagrams at the top, that's the base. Even though this is on the side, it's still the base because it's one of our pairs of parallel and equal sides. That's the base. We could use that as the base, the top. It doesn't matter, as long as it's one of my equal and parallel sides. Okay, so as a result, you just need to know how to calculate the area of a triangle, the area of a rectangle, and the area of a circle. You don't have to worry about the hexagon. So you guys already know how to do that. So there's actually no more work to be done for volume of a prism. Now, in terms of surface area, it's a bit different for each one. However, the idea is very much the same across the board. So the idea is to more or less unravel the shape into its net and then work out the area of each face and then add it up. The book really stresses drawing the net in a lot of the questions. I think you guys are at a stage where you don't need to draw the net for each one. However, if you find yourself making lots of mistakes, and some of you will because this is a topic that encourages silly mistakes, then I really want you to make sure that you start drawing the net until you fix those mistakes up. So very quickly, let's go through the surface area of just one of these. I'm just going to look at the triangular prism. So in this case, what I tend to do is just color it in each face as I go. So for instance, I know that the top, it's not a very clear pen. I know that the top and the bottom face are going to be the same. That was my condition for it being in a prism in the first place. So I know I'm going to have 2 times T1, my triangular face 1. Okay. Then I'm going to have the back face. So I can't draw on this because I'll fill in the other ones, but you just got to think about the back face. So that back face is going to be a rectangle, right? So we're going to have R1, and then we're going to have this face here, which is R2, and then we're going to have this face here, which is R3. I'm sorry there's so much scribbling on there, but hopefully that's clear enough. So we more or less have 4 calculations to do. The way I've set it up is precisely the way I want you to set it up. Okay, so with 2D shapes, you could draw the sign for the shape. So with 2D shapes, we said we could do things like, okay, this one or that one or so on, whatever. With 3D shapes, that's too hard. Okay, so I just want you to give it a name. So you might actually write on here, T1, T1, R1, R2, R3, and then do it that way. But labeling on the actual shape is not necessary, and I don't want you to draw out the shape in your book. Okay, so I just want to get you give each one a name and then perform the calculation. So we're going to get to the actual calculations later, but if you've already started 12.5 or 12.6 or so on, and you're happy with the actual maths behind it, this is where you can stop watching and start doing some work. All right, so this is the setting out, and at the end you just add them all and find a total. Remembering to give the units as well. So with surface area, it'll be something squared. With volume, it'll be something cubed. All right, so for those of you that want a bit more practice with these, let's have a look at a couple of examples. So the first one we have is a rectangular prism. I know it's a prism because I have this base, which is parallel and equal in size to the top face. All right, so I'm going to start with volume because it's easier. Cool. So volume of a rectangular prism is going to be the base, which is 2 times 5. Right, so this is what I mean when I say my area of the base. All right, so I'm just working out this bottom rectangle, which is 2 times 5, times the height, this thing here, so that's 3. And so if you work that out, you should get an answer of 30. Note, he would lose a mark here. Okay, so make sure it's 30 meters squared. For surface area, you should recognize that we've got 3 pairs of sides here that are equal to each other. So the left and the right, the bottom and the top, and the back and the front. Okay, so we're effectively going to have R1, R2, and R3. Let's call the bottom one R1, let's call the left one R2, and let's call the back one R3. So bottom one's R1, 2 times 5 is 10 meters squared. Actually, if I go back, I've made a mistake here, right? So this should have been cubed. Hopefully, lots of you are shouting at the screen at this point. Okay, so R1 is 10 meters squared. R2, which is my left side, well, I've got 2 by 3. So 2 by 3 is 6 meters squared. And finally, my back side is 5 meters by 3 meters. My back face. So 15 meters squared. Right, then the total is just 2 of those each added up. So 2 times R1 plus 2 times R2 plus 2 times R3, which is equal to 2 times 10 plus 2 times 6 plus 2 times 15 equals 62 meters squared, I think, if you add it up. All right, so volume should be cubed. That's the mistake I made earlier. Surface area should be squared. Okay, let's keep moving. Let's have a look at example 2. So with example 2, how do we know it's a prism? Well, we have this side, or this face, sorry, and this face, which are equal and parallel to each other. All right, so that's going to be our base in our volume formula. So we'll start with volume. And so the volume is area of base times height. And the area of base in this case is half times 4 times 3.5, just my area of a triangle, right? Triangle. And then we multiply all that by the height. Now note here the height runs across. The height is just the line of the side connecting the 2 faces that are equal and parallel, okay? So it doesn't have to be going up or down, it could be going left and right, that's fine. So times 6. Now, if I work all that out, I think I get 42 centimeters cubed. Okay, but check that with your calculator, but hopefully it should be right. Then we look at surface area. Okay, so again, we're going to have at least one pair of sides that's the same. That's my triangle pair, so T1, T1. I'm going to have my bottom face, So this bit here. So I'm going to call that R1, so rectangle 1. And finally, I'm going to have my two slope faces. So that would be one of them. So the one I'm coloring in now would be one of them, and the one on the other side would be the other one. So R2. All right, so for the triangle, we've already worked out the area. Or actually, no, we haven't. It was this, a quarter times 4, not a quarter, a half times 4 times 3.5. If you work that out, you should get 7 centimeters squared. The bottom rectangle is 4 centimeters times 6 centimeters, and I might just kind of clear up this diagram a little bit because it's getting really, really messy. Okay, that's better. All right, so R1, this bottom face, is 4 centimeters by 6 centimeters. So 4 times 6 equals 24 centimeters squared. And finally, each of these sloping faces, so is this times that. Now, notice that we don't actually have, or we're not actually told the length from here to here. But again, if we get rid of all this mess, we can see that we have these symbols there, which indicate that all sides are the same. So actually the slope will also be 4 centimeters. And so R2 will actually be 4 times 6 equals 24 centimeters squared as well. And then the total, well, we get 2 times the triangular faces, right? So 2 of these, plus 1 of the bottom, R1, and plus 2 of the sloping faces, R2, so rectangle 2. And so all up, we get 2 times 7 plus 24 plus 2 times 24. And if you do all that, I believe you will get 86 centimeters squared. But again, do check that on your calculator. But this is precisely the setting out I want, okay? The only line that you might be able to skip if you want is you don't necessarily need that line, okay? So that line is sort of optional, but all the other lines you do need to show me. And if you show me, then you can get partial marks for these as we go, okay? If you just jump straight to here and one of these is wrong, I can't give you a mark because I don't know where these numbers have come from, okay? So it has to be very systematic, very sequential, one after the other. All right, last one. Example 3. So this time we have a cylinder. Now, over here, fun fact, cylinders are prisms. This is something that I say to people and then they forget, and then I tell them again and they act surprised. Cylinders are prisms. Okay, you must remember this. It's really important because then it makes the calculation a lot easier. So, if a cylinder is a prism, which it is, when we work out the volume, all we need to do is the same as before, area of base times the height. Well, the base here, the reason we know it's a prism is because we have these two faces that are opposite one another, they're parallel and the same size. Okay, so to work out the area of a circle, that's what we have here, we of course need, first of all we need the black pen, but we need pi r squared times height. Now, we're not going to fall into the trap that they're setting for us and use 17 because that's not the radius, right? That's the diameter. So the radius, and I'll write in here, r equals 17 on 2, which is 8.5 centimeters. Okay, so we have pi times 8.5 squared times h. Now, what's the height? The height, we're told, is 21 centimeters. So I can straight away write in 21. Okay, so we have this one here. So we're going to get, I think it's 72.25 pi times 21. But again, please check that calculation. So that one there on your calculator. And from here, it's just a calculator question. Okay, so you put that in your calculator and whatever it is that you get will be in centimeters cubed because we're dealing with a volume. Okay, so you can do that one yourself at the end. Finally, the surface area of a cylinder. All right, so the idea is basically that if we unravel a cylinder, we're more or less unraveling this middle bit. okay, we're unraveling this middle bit. The circle, the top and the bottom will stay the same. So we still have two circles, top and bottom, that have a radius of 8.5. So that doesn't change. But this bit on the side, when we unravel it, we get a shape. Well, it will still have a height of h, so that thing doesn't change. But when we unravel it, this side here is actually equivalent to the circumference of the circle. So it's equivalent to that there. To convince yourself, take any A4 sheet of paper and just fold it around and see that it forms a cylinder, okay? And so the circumference of a circle we know as 2 pi r, and so that's actually the longer side of our rectangle. Okay, so we need to work out the area of each of these. We start by the area of the circle. So area of circle, well, we already worked it out. It was this thing, 72.25 pi. And then the area of the rectangle, you can still use C1 and R1 here. I'm just doing it a bit longer way this time. So the area of the rectangle is 2 pi r, which is 2 pi times 8.5 times 21, which was h. And so for this one we get 357 pi, I believe. But again, check with your calculator. And so the total is 2 times 72.25 pi plus 357 pi, and so the answer is going to be something centimeters squared. Just do that on your own calculator. All right, so we've done triangular prisms here, we've done rectangular prisms, we've done cylinders, and another word for cylinders might be circular prisms. Okay, so you should now be well equipped to do all the questions in 12.5, 12.6, and 12.7. Yeah. Okay, so just work through your checklist, and I will see you tomorrow.